All right, we're going to look now at section 10.4, compound events. Now, it's important you understand that a sample space, fill that word in, is a set of all possible outcomes of one or more events. So, sometimes you want to make a table or tree diagram to find out what the sample space of 2 or 4 events looks like. So let's look at this example with pizza. You randomly choose a crust and a style of pizza, and you want to find a sample space to find out how many different pizzas are possible. So you don't have this on your paper, but up here my crust choices are either thin crust or stuffed crust. So that's the first thing you've got there on your table. And then you can either have Hawaiian, Mexican, pepperoni, or veggie. So for your styles, and you can just go ahead and use like H for Hawaiian and M for Mexican, but you want to fill this in. So you could see that you could have a thin Hawaiian pizza, or thin Mexican, or thin pepperoni, or thin veggie, and the same thing for stuffed. And once you know what your tree looks like, you can write out your outcomes. You could have thin crust Hawaiian, thin crust Mexican. I'm okay if you abbreviate on these, but I do want you to write the outcomes. Thin crust pepperoni, thin crust veggie. Same thing with stuffed Hawaiian, stuffed Mexican, stuffed pepperoni, and stuffed veggie. So it says on your paper a number of types of pizza where there are 8. We can count them down. There's 4 here and 4 here, so there would be 8 of them. And it says, what would the number of outcomes be if the shop added deep crust? So you'd get a whole nother set if you added deep crust. So you'd have to add a whole nother 4, so you'd have 4, 8, 12 different outcomes. All right, this one's not on your notes, but here we're looking at flipping 3 nickels. And it says, what is the probability of flipping 2 heads and 1 tails? So I have right here the sample space for it. The first options were heads or heads in red. And then in blue, you could have got heads or tails with your heads, or heads or tails with the tails. And then green would be the third flip. So then here are our possible outcomes. On the probability of flipping 2 heads and 1 tail, you can see that heads twice and tails once only happens 3 of the times. So we would say 3 out of the 8 would be tails. So that's one use of a tree diagram, is it can kind of help you visualize what your outcomes are. All right, here's another one that's not on your notes I want you to look at. It says, use a tree diagram to find the sample space and the total number of possible outcomes. You're going to be drawing tree diagrams on your homework today, so I want to make sure you understood how to do that. So we would say amusement park. We'll abbreviate like that. You could go to the zoo, or we could go to the beach. Now, for the amusement park, I could go in a car, or I could go on a plane. For the zoo, we could go in a car, or we could go in a plane. And also for the beach, we could go in a car, or we could go in a plane. So it says, use a tree diagram to find the sample space and the total number of possible outcomes. So my sample space would be, we'll do A for amusement park, car, amusement park, plane. We'll do zoo in a car, zoo in a plane, and beach in a car, and beach in a plane. This is my sample space. And the total number of outcomes, well, we just count them and say there are 6 outcomes. So that is how you list a sample space and the number of outcomes. So I'll just walk you through that really quickly, seeing what those are. So 3 times 2 is 6 outcomes. Notice that I had 3 options here and 2 on each of these. So we counted them up to be 6, but you could have multiplied them. So that brings us to our fundamental counting principle. This is going to be very key today. Instead of actually having to draw out a sample space, you can use this. It says an event M has M possible outcomes, an event N has N possible outcomes, and the total is figured out by multiplying the possible outcomes M times N. So if we look at this example here with the pizza, there were 2 possible crusts, and there were 4 possible styles. So 2 times 4 is 8. So without having to make a sample space, you can figure out the possible number of outcomes. So it says find the total number of possible outcomes of rolling a number cube and flipping a coin. So with the fundamental counting principle, number cube has 6 possibilities, and the coin has 2. So we would just multiply those together, to figure out. So using this, I would say 6 times 2. I know there are 12 possible outcomes. So look at this one. How many different outfits can you make from the t-shirt, jeans, and shoes? Well, t-shirts, we've got 1, 2, 3, 4, 5, 6, 7. Jeans, I got 1, 2, 3, 4 pairs of jeans. Shoes, I have 3 pairs of shoes. So the total number of outfits, if this is all you have in your closet, is probably a lot higher than you would think, because 7 times 4 is 28, and 28 times 3 gives you 84 outfits. They're considering that different shoes is a different outfit. So the fundamental counting property makes it much faster. So a compound event is 2 or more events together, and you're going to find the number of favorables over the number of possibles, which is what we've been doing all along. So it says find the total number of possible outcomes of rolling a number cube and flipping a coin. Well, we already know number cube was 6. Coin was 2, so we know there's 12 possible outcomes. And then it says, what is the probability of rolling a number greater than 4 and flipping tails? Well, we could look at this to help us out here. A number greater than 4 would be 5 and 6. But then the flipping tails, how many of these? There's only 2 that have that out of the 12. So you say 2 out of 12, or 1/6. You could do that without a table, though. Probability of knowing a number greater than 4 was 2 out of the 6. Tails would be 1 out of 2. And if you work this out, you get 2 12ths, which is 1/6. All right, what is the probability of rolling at most of 4 and flipping heads? The most would be 4 and lower, and 4 and flipping heads would be these 4. So we know it's going to be 4 out of 12, or 3/4. I'm sorry, 1/4, 1/3. Sorry, 4 goes into 4 once, into 12 3 times. But you could say at most 4. Well, that's 4 out of your 6, and heads is 1/2, which gives you 4 12ths, which is 1/3. So you can look at probability with a table, or you can write your fractions and just multiply. When you have a compound event or more than one thing happening, you multiply. So you flip 3 coins. What's the probability of flipping at least 2 tails? The sample space is very helpful in this case because we can tell which ones are 2 tails really quickly. Your homework is on page 425. Please do your homework quiz when you are done.